Hi everyone, welcome back to another episode of the AI Spy. We haven't done a recent episode in the last few weeks. It's always difficult to find A-listers and topics that are interesting to both you, but also interesting to me. But today we have a very special episode. I say special because we are joined by Dan Fernandez. Dan Fernandez is a returning guest on AI Spy. The top three rated episodes, two of the top three rated episodes of AI Spy feature Dan. And I think now it's going to be three on three. So, what we want to talk about today is very exciting as well. Recently, in last month, a security researcher auditing an unrelated code base just stumbled onto a flaw in Starlet. Now, Starlet is this Python framework that underpins most of the AI infrastructure. And the fun thing about this is they didn't go looking for that. They were not looking for it. They just stumbled onto it. They just found it. This raises a question on vulnerabilities that exist in software, but also vulnerabilities that AI is introducing or vulnerabilities that exist in the AI infrastructure. So to unpack this interesting topic, I have Dan. Dan is a cybersecurity expert and product management at Edera. And Dan, welcome to the show.
Yeah, thank you for having me again. I'm looking forward to this conversation.
So Dan, last time we were talking about doxing. That was a fun episode. It's almost a little over a year now, but what have you been up to since the last time that we spoke?
Yeah, since then, I've been working on AI infrastructure security, focusing on like how to reduce the blast radius of these tools that we're gonna talk about today, and just generally focusing part-time at Georgia Tech Online Masters of Cybersecurity program as an instructional associate, and just trying to keep up with all the exciting news and trends in technology broadly.
Yeah, and there's quite a lot of it. I was reading somewhere that in 2026 alone there were 40 CVEs that were identified in MCP implementation. So I'm sure there's a lot that is keeping you busy. But let's get into our topic. But let's start with the basics. And before we go into BadHost or this specific vulnerability that was surfaced in May 2026, let's talk about someone who's never had to think of vulnerability management. What is that, and why does that matter?
Yeah, for sure. So vulnerability management is definitely an interesting topic right now because of different trends in technology, like you said. If I had to describe it simply, is basically how to ensure at a high level that all the components that are going into software are secure. And I think this is to give a more interesting or relatable analogy, you can think is like an application as building a house, and you're going to need different components for that house. You need the foundation itself, you need sheetrock, you need wood, you need all these things. And you can think of vulnerability management as trying to identify that not any one of those components is compromised in any way. So, and that is typically referred to as supply chain security, meaning like you're looking at the supply chain of all the software components that are going into your application and trying to verify that they're not vulnerable. The way this typically works is that you have vulnerability scanners, and what these vulnerability scanners do is that they are looking at software versions at a high level, and they're trying to compare, are there known vulnerabilities that exist in this piece of software, and if so, they will flag it based on that vulnerability's criticality. An interesting part here is that this has a very strong dependency on something called the National Vulnerability Database, which is maintained by the government, and this is kind of like a centralized database that keeps track of what are all the existing vulnerabilities and which ones are more or less critical depending on how easy it is to exploit or how widespread the issue is and with what kind, like how many software components it affects. The more interesting part of this too is that that particular department or area of the government has kind of like struggled to keep up with the number of vulnerabilities because of what you described earlier. It's like both the sheer number of things that are getting found by AI and in general are kind of like overwhelming that process of enriching the vulnerabilities. So if you have a vulnerability scanner, but there's no up-to-date information on how critical something is, or even process like a long list of vulnerabilities, that means that your vulnerability scanning process is not as effective. So that is one of the bigger challenges. But to sum it up, vulnerability management is typically a process where you have to you prioritize any flaws that you find in that software, and based on whether or not they get exploited, you then decide to update software or patch software. In developing new things, it could be like bumping a software version of a software component. If it's at the operating system level, upgrading that as well. So that is in a nutshell what it is kind of like, how do I ensure that all the components that are going into my application are trusted, for lack of a better word.
So it's like, every now and then we get our iPhone, there's an update, and there's a new update which says this update addresses blah, 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 blah. Some of them could be just from new functionality, new value that they've added, but others could be addressing critical security vulnerabilities that protects the software, that protects the data that the software has access to. So that's, thanks for explaining the basics. Now, you briefly mentioned it. Now with AI, that there's so many things that are getting discovered. So how has that process, if it has changed? I know AI is then embedded into everything, into the systems we run, into monitoring the systems we run, into testing. But how has overall the vulnerability management changed in the age of AI?
Yeah, for sure. So the first thing I'll start with is the fact that in the past, you could think of traditional software as deterministic, meaning some software engineer had developed logic that is written into code, and you can expect that anytime that you run that program, the same behavior will happen, right?
Yes.
And this is the biggest thing that has changed with AI in terms of vulnerabilities, is that AI is a probabilistic type of system, meaning that every time you ask an LLM a question, it is generating a set of predictions on what the output is going to be. So what that means is that you're going to get inconsistent answers every time you ask a question by design. But this also means that you get very unpredictable behavior from that system because of how it's architected. So what does that mean for vulnerabilities? One of the biggest threats to AI agents in general is this concept of prompt injection. And a prompt injection is essentially a way to inject behavior that is unintended for the underlying system to perform. So as an example, I could tell that system to ignore security safeguards and then access underlying data or underlying databases. So now what used to be a non-existent vulnerability is prompt injection is now like the entry point for any potential system that exposes an AI agent. So that's like one spectrum of vulnerabilities that are available. The biggest takeaway here is that prompt injections are kind of a cat and mouse game. Like you can proactively add more and more rules to identify what is known to be bad behavior, but this is something that you constantly have to update. So there's some mitigations for that, what is called or known as guardrails, but that has to constantly evolve. Now, the agents themselves are running on traditional infrastructure. So this is many times abstracted as an end user of something like ChatGPT or Claude. Is like someone somewhere is running this thing, but when you're building AI agents inside of your organization, you're hosting that code in your existing infrastructure, whether that's a cloud service or just a general server. Now, what that means is that we are introducing a lot of new tools and dependencies, like the dependency that we're going to talk about, that bring less, validated pieces of software into the whole discussion. So an example of that is MCP servers. So MCP is Model Context Protocol. And what that does is that it allows a user to interact with outside systems in a standardized way so that the AI agent can communicate with a third-party application. It can communicate with a database. Now, the main challenge with MCP servers is that while there is a standard on how to build them, a lot of companies and individuals are kind of like building their own. So they're introducing vulnerabilities themselves, where it's like, hey, I am Dan. I want to build an MCP server that gives me access to all the travel sites because I like to travel and I want to find some interesting place to travel. Now I'm using AI to generate code for that MCP server. So the AI prediction issue, like the probabilistic error that the AI can introduce as a software bug, is there. And I'm creating a net new surface, that is the MCP server, that could also have vulnerabilities. The main challenge with all, like, the value of AI and AI agents comes from giving them autonomy or giving them the ability to make what is known as tool calls. So it's like, I'm gonna try to solve the problem for you based on all the tools that I have access to. But all those tools also are untrusted software that is coming from someone on the internet. So in a nutshell, the underlying architecture of AI models introduces untrusted code because you have a machine that is constantly generated code that has not been validated. You're introducing new software components that themselves are very new to the industry that require scrutiny and validating that they're safe. And then you have all the existing software vulnerabilities that power these applications in the first place and all the infrastructure. So it's a combination of multiple things happening.
Okay. So if we talk about this vulnerability, it's called BadHost. It's been nicknamed BadHost CVE 2026-48710. I had never heard of, I'm okay to admit this, I had never heard of Starlet before I started reading about this. So maybe a little bit about what it is and why this is so concerning. I was looking at the scale without really understanding what it does. I was looking at the scale of this framework, and there's like everyone from Microsoft to Uber to many other large corporations and enterprises for their applications, they use this particular framework. So the scale wise, it's very big. But what is it, and what does it? Why is it so fundamental to the AI infrastructure?
Yeah, so what you just admitted to, and there's a lot of these examples, is that modern software engineering relies on sourcing dependencies. Like when you're, in this case, building a Python application and you want to build certain functionality, you have two options. And well, this is true for any ecosystem, not just Python. It's like you either build something from scratch, meaning you're going to build every single expected behavior that your software is going to do, or you're going to import a library that already does a lot of that functionality, and then you build on top of that library. So Starlet is an example of a library that focuses, if I had to like simplify it, it's basically the routing of requests that are going into the application. So you can think of it as like a traffic cop, or you can think of it as a way that kind of like directs a request that is coming from a user to whatever system it needs to access. So if it's a database query, then that is kind of like the routing mechanism so that it goes to the database. If it's some other data source or other module of an application, that is kind of like the routing that gets it to where it does. The main challenge with this particular vulnerability is that it essentially allows like bypass of unauthenticated bypass. So meaning like without being a logged in user to the system, depending on the request type that you forward to it, it could allow you to bypass security controls and have direct access to areas of the application that are not intended to be accessed externally, right? So what exactly does this mean? So why is this one tricky? It is tricky because of that unauthenticated access. Vulnerabilities, what we were talking about at the beginning, sometimes the criticality is assigned based on how easy it is to exploit, whether or not you need already. So there's some vulnerabilities that are very hard to reach because you need to be an admin user in a system to be able to access it. And then there's vulnerabilities that are more critical in the sense that anyone can potentially craft a malicious payload. Log4j is another example of this type of vulnerabilities where you could send a request to a public facing server, and then you would have kind of like remote access to that system without any sort of authentication. So that's why this one is particularly tricky. Why is this important or interesting, or why are all these types of vulnerabilities interesting in the context of AI? As I mentioned earlier, the value of this AI agents relies on, one, autonomy, but two, in access to systems. So what traditionally enterprises or individuals end up doing is that to make that AI agent useful, you give it access to your email, you give it access to your calendar, you give it access to this thing. So now basically any vulnerability on that agent framework, and Python is a language that is widely used for some of these agent frameworks, now then gives a potential malicious user access to data that they should not have. So what this means is the more or the less that you compartmentalize and isolate your trusted resources, the more at risk you are of something like this, where if your agent gets compromised, it basically gets access to everything. So that's why it's interesting.
Earlier, when you were speaking about blast radius, this is like the more connected your agent is, the more capabilities it has, the access to more access to systems. Some people marvel like, I've done an amazing job. I have this agent that can access my emails, look into my calendar, set up my to-do list, has access to my file system because it can go and write things for me. It's just vulnerabilities like this are increasing the blast radius, if you will, for the threat actor. Is that a good way?
Yeah, that is exactly the way to describe it. So there's been some progress in terms of like starting to realize how big of a potential problem this is. I think there's a number of technologies that allow you to quote unquote isolate AI agents. And we can spend probably another hour or so like going into the weeds about like whether or not one technology is more or less effective. But what you describe is the important part. And I think what people need to start to realize is that you need to have isolation of these new systems to ensure that if one thing gets compromised, everything is not exposed. And it's almost like insecurity and in general is kind of like a breach is bound to happen and you should almost like assume it will happen. It's like, how do you make sure that you minimize the extent of that breach once it happens? That's the best we can do. And part of the reason why this is critical in AI agents specifically is what I mentioned at the beginning about prompt injections. Like that remains the unsolved problem for initial access to a system. Is like there's an infinite number of ways to achieve a prompt injection. And once you achieve a prompt injection, you take control of that agent. And if that agent is connected to everything, now you get access to everything. So yeah, that the way you set it up is basically a good way to describe
your words. When you was in the introduction, when you were talking about blast radius, I was thinking, wow, this just keeps expanding the blast radius because agents are so, and we're connecting so many things, giving agents access to so many different applications, data sources, so that the agent is productive. But at the same time, we are exposing all of that to threat actors now. So you did explain why this is a particularly bad one. Just the reason that we explained, because it can expose so much. So there's a lot of these vulnerabilities that are being also discovered using AI. Like Mythos exposed so many. It was in news, this project Glasswing, but they somehow missed this one. And does that tell us a little bit about where AI assisted security tooling is strong versus there is still areas where it isn't?
Yeah, that's a good question. I mean, I would say, so just to provide a little bit of context, maybe for folks that are not as familiar. So this Mythos model is a frontier AI model that has been released by Anthropic, and it focuses very specifically on vulnerability and security type identification of issues. And what's interesting here and is worth highlighting is that because this model was so powerful, it was that this project Glasswing was created, that it was like, how do we make sure that before we make this widely available to the general public, we can at least proactively find what are the more critical open source software libraries, what are the more critical software components that we know the whole world is using. Let's try to mitigate any security issues with those and then release more broadly. And the point you bring up is a valid one. It's like, well, one, why wasn't this found? It could be that because it's being constrained to very specific projects, it could be that this one library or this one project was missed because there are dozens of thousands of, or millions essentially, of libraries that exist in each language, right? You have Python, you have Java, you have Rust, you have Go, you have basically a ton of surface area. So this is one of the challenges where, and some of the debate is going to, is like, hey, we need to be really mindful before we release these frontier models into the wild, because realistically, it is untenable to be 100% sure that every piece of software has been audited and analyzed in open source alone. Now, when you take that a step further, part of that Project Glasswing effort also relied on, hey, not only do we have to look at those open source components, but what is critical infrastructure, financial services, insurance, healthcare, that we also need to verify internal code of those companies, not just open source code. And this is the thing maybe that we kind of cover, but just want to emphasize it. When you're building software, you are inheriting potential risk and you get a ton of benefits from the open source components, but you're always building on top of that. So when you're building on top of that, you're also potentially introducing security issues yourself as part of the logic that you're bringing to the table, right? So now imagine, even if we're able to cover every possible open source library and software project through Mythos or similar initiatives, we now have to do the same in every enterprise potentially and find those security issues on code that is not public, that this effort cannot like proactively identify. Not sure if that answers your question.
No, it does. It does answer my question. Thanks for that. So I'm not sure if I'm going to keep this part. I'm going to ask you still because I'm very, very curious as to what you think. What I'm worried about is this. And see, Anthropic is a very responsible company. They do the right thing. Even with Mythos, they did the right thing. They took it to large organization. They formed Project Glasswing was instituted. But the fact that an AI model, a frontier model, is being trained to identify vulnerabilities, and they are trying to do this. Their intentions are right. They're trying to, like you said, they're trying to find these and address this before it's open and available to the general public. But the same applies for the bad side, the fraudsters, the hackers. They could also be using similar technology, AI, to find the vulnerabilities, not to protect, but to exploit. So it's that duality that exists. So that is what worries me. I don't know if
that's a super valid concern, and that is an ongoing debate that has been happening ever since the accelerated progress of AI has begun. So maybe let's double click on that particular dynamic you just described. So there's two schools of thought, right? One says that you should not have open source, open weight, freely available frontier models because of what you just described, where a e-crime group, a nation state, anyone could potentially, and this has happened already, by the way, it's like build a piece of software that its only purpose is to write malware instead of find security issues. Right. So one school of thought says, if we have overall control and everything is closed source, and we can validate that anyone getting access to this thing is a good person, then we can have control of all the things. And that argument is kind of shaky, in my opinion, because then now you're giving the power to a degree to whoever has those closed source models. The alternative is that by having open source models, scientists, researchers, universities, everyone is able to proactively find those issues because it is open source and maybe build defensive tools based on their understanding of that technology. But as you can see, like it's basically, but then someone would argue, well, if we make everything open source, the bad actors will use it in a negative way.
So our hope is, in the second school of thought, the hope is that open source, everything should stay open source. The good side has access to the same information, but they should be able to do, like, if we should continue investing in research, building these defensive or even offensive tools to get ahead of these attacks so that we can harden our software so that there's no vulnerabilities left. So that the good side doing their job a lot better than the fraudsters, the e-crime groups. I guess that's That's the hope.
Exactly. And the main thing here is that they're kind of both right, but they're also flaws for both approaches. And I think we're seeing competing efforts basically in certain geographies, namely the EU. There's a lot more control on
Mhm.
the development of capabilities. Oddly enough, we're seeing that most, until very recently actually, yesterday NVIDIA released a new model called Nemotron Ultra, which is an open source, open weights model. It's not as
Powerful.
bleeding edge and as frontier and as powerful, to your point, as the big AI labs, but it's a very, very capable model that is now open source. And
Mhm.
the reason why I say this is because it's almost like China has been taking the approach of open sourcing DeepSeek and
Yeah.
Quen and a lot of either all of those other models, and the US has taken the approach of let's safely release the models with things like Project Glasswing. Again, we'll see how which approach is better, but the challenge is that we don't live in a vacuum, right? Like some
Mhm.
countries are going to do one thing and some countries are going to do another thing. And the bad actors are going to find the best way to be themselves.
Yeah, I
So
mean,
that's the main
that's their
challenge.
advantage, right? They're not bound by jurisdictions or regulations. Bad actors can do whatever they have to with the least path of least resistance. So Dan, this is very, very interesting. But I always want to finish on an optimistic note. So we both know that enterprises are under huge pressure to adopt AI. This AI generated code, AI assistance, everything is being introduced. So if you're a CISO or a fraud executive at a bank, at any large enterprise, should you be worried about by this, or what are the first things that you should do? And again, see, I have no illusions that you and I, two product managers, can go and guide a CISO. They know their job very well. But for the listeners, I don't want I want them to have some comfort that there is a path forward. It's not doom and gloom, and it's not that, oh, AI is going to be used to exploit everything, or everything you build using AI or frameworks are vulnerable. So that's what I wanted to ask you.
Yeah, for sure. I mean, I think for better or for worse, what we're seeing so far is that history is repeating itself in the sense that initially, when a groundbreaking technology becomes available, everyone is trying to run to the market and be the first one to release it.
Mm.
And some of the security aspects are overlooked. But I would say that from the how everything is going, there are definitely a number of initiatives that are in parallel building best practices for what does a good AI agent deployment looks like, what is good isolation. The main thing to highlight here is that some of the boring stuff that we were supposed to do before still applies, meaning good data governance is
Yes.
probably the most important thing for any enterprise to do. Because why? If you have a good data governance, you know, one, where does the valuable data that this AI agent needs actually located in my enterprise? And that's important to make it useful and usable. But at the same time, from a proactive security perspective, if you don't have good data governance, you're not able to properly isolate the blast radius or that agent from being compromised. So it's like knowing where your key assets are and then creating the right security boundaries around them. So things like, does this agent have access to data that it shouldn't? Am I able to first account for who's using these tools inside my organization? Am I logging data access to the different systems so that I can then, if worst case scenario, retroactively try to address some of these challenges, but at least know where to set the boundaries for the systems to access or not access.
Yeah, you just reminded me in an episode we did in back in 2022 or late 2022, early 2023. One of the favorite things that you mentioned is the boring parts of AI. I even have that clip. So it's all fun with these models. There's a lot of things, but we need to do the. I always say we need to do the boring parts perfectly so that we can do the exciting parts well. Dan, thank you for joining me. Thank you for sharing your insights. It's been, as always, it's great talking to you. And Thank you for making time today. So everyone, it's a wrap on this episode. We'll be back again with another A-lister, another interesting topic for you. But until then, bye.
Yeah, thank you. It was great to be on again.
Thanks, Dan. Bye.